Welcome to Precision Pilot, an aviation channel focused around flying unique airplanes, building, updating, and maintaining aircraft, and adventures in aviation. I'll explain the process of preparing, painting, and laser engraving aluminum using a hobbyist level laser engraver. The techniques I'll outline in this video have been used successfully on several projects over the last year. The catalyst for buying this and developing these processes was redoing the panel in my aircraft. The Flight Design CT I purchased was configured as a basic VFR bird. My project was to fabricate new instrument panels, and the inspiration was framed around the designs found in modern jet aircraft. Here's a picture of the final result. Today we're working with 25 thousandths 6061 T6 aluminum. We removed the protective film from one side, exposing the factory finish, and you'll see that's the typical shiny aluminum. And to prepare it for paint, we'll DA sand that surface with about 100 grit paper, and that accomplishes two purposes. First, it roughens up the surface to allow the paint to have a substrate to adhere to. Secondly, it provides us a nice uniform matte finish for later on in the process when the laser etches the paint off of it, we have a good uniform matte appearance of our characters and text through that paint. Let's get started. With the metal prepared, it's now time for paint. And it's possible to use a rattle can, spray it, but I find that when you try to paint smooth aluminum with a rattle can, all the little imperfections show up, whether it's dust, lint, fish eyes, little specks, plus the thickness of the paint that you get on the surface is a little thicker than what's desirable. It works, but it's just not the optimum finish. So what I chose to do is to decant the paint from the rattle can into a jar and then use a touch-up gun, which allows you to dial in the finish a lot more uniform and a smoother, better appearing outcome as well. The other thing it allows you to do is blend and mix paints to come up with the perfect color. Now, I wanted a dark charcoal metallic for the project I was working on. And metallics typically have a translucent carrier to them, so when you paint them on a lighter color, you have to put so much on to get the color to be correct. It's kind of a struggle. And they weren't dark enough. So I took a satin black, mixed it about 50-50 with the charcoal that I wanted to have some metallic look to it, stirred it up in a jar, and it's perfect. It's the nice uniform color that I wanted, and lays on with a thin film build to get a good appearance without having to put it on super thick. So we'll load up the gun and we'll shoot our aluminum for the next step. And now for the fun part. With our paint fully cured, I like to give it a day or so, we'll fire up the laser. I'm running a Vigotec VG-L7. This is a 20 watt laser. It's belt driven in the X and Y axes, and then the Z depth is a focal distance that you set for the thickness of the product that you have underneath it. Works real well. It's a simple $200 basic entry-level hobbyist laser, but I've been really impressed with what it's capable of doing. It comes complete with everything you see here. You simply use a USB drive. The included software is run on a PC, and the artwork can be created from any simple application such as Microsoft Paint, or I like to use Inkscape. That's a wonderful freeware type graphic package. You can design your stuff, snag a JPEG bitmap, just basic image files are brought in. Then once the image is loaded into the software, you scale it for the dimensions that you want on your final product. So we'll fire up the laser and I'll demonstrate how we confirm the location it'll etch, and then talk a little bit about the settings as well. The intent of this video is not to be a complete tutorial on all things running a laser engraver. There's plenty of those out there on the internet. I will give you some pointers, however, though. I like to clamp the laser to the workbench as the head is belt driven through the X and Y axes. This keeps it from creeping and walking around, so you have a good clean etch on your workpiece. Also be aware of your cable management. I've had to tape this cable here. It once looped around in the back, and then as it traversed, it kind of messed things up. So don't leave things laying around where these cables are going to be sliding around on the workbench. Also, safety first. Don't even think about running and looking at one of these things that are the uncaged lasers without the proper vision protection. These are some nasty lasers that are serious harm to your vision, so don't take any chances on that either. And a little bit about the settings. For the speed on this unit, I'm running about 750 to maybe 1250 millimeters per minute for the speed. And then the setting, because this is a 20 watt laser, I'm almost maxed out. I'm usually 90-95% on the power setting. And the etch process on this particular laser is 13 dots per millimeter in how it's pulsing to etch the surface. And I have a pause rate between etch start and stop locations of 45 milliseconds. That's not real critical, that's just a number that I've always used. So your settings will likely vary depending on the process that you're using, but that should get you in the ballpark as some indication of what's been working well for me. So we'll fire up a range preview here, and I will hit range preview. You'll see the lasers possibly reflecting on the surface there. This is a low laser pulse to depict the size of the etch of where it's going to go on this workpiece. And I'm cutting out a placard from this panel that I'll be making here. And all I need to do is be within the edges. So I've kind of tucked it off to the corner here, and that looks like a good place to start. With everything confirmed as far as the location of the etch in the settings, we'll now hit start. I've got my glasses on, and we'll fire the laser up. With the etching process complete, we'll shut down the laser, make some room here. And the initial outcome is not that hot. You'll see it's kind of a sooty mess on here. So to clean it up, make it look nice and pretty, we'll take some cotton balls and some isopropyl rubbing alcohol and get the cotton ball pretty wet. And then just rub it. Let the alcohol kind of remove some of that soot. A little bit of pressure. I'm not going real crazy here. And this is why it's important to let the paint to fully cure, because the little bit of residue that builds up on these cotton balls, if the paint was soft and freshly painted, it can dull or kind of mar the surface a little bit. But if you have a good cured paint, this scrubbing with the alcohol and cotton ball, it still leaves your surface nice and intact, shiny if you have a glossy paint. This is a semi-matte with the mixture that I put together, so if it was a real flat black or something, it might have a little shine develop from this, but you have to clean it up, get all that residue off of there. And as it looks, shiny and begins to develop the artwork, you'll know that you're done.
you really can't overdo it. It's just rubbing alcohol and a cotton ball, right? It's not anything that's going to damage the aluminum or the paint. I think that looks really good about right there. I usually don't have to scrub that hard. I think I put the paint on this surface a lot thicker than I have my past projects. In fact, I can even feel the thickness through the paper toweling here of the paint versus where it's not painted. There's probably 1 to 2 thousandths thickness of paint to give you an idea of how thick of paint that was on there. And there's the nice final product, all cleaned up, ready to get cut out and turned into our placard for the plane. For little projects such as this one, I prefer to etch the piece of aluminum with extra space around it, rough it out on the bandsaw, and then I'll clean it up with a belt sander to give me a nice finished profile around the outside so it has a factory finish appearance to things. Here's our final product. See, it has a real professional look to it. Little double-side tape to the back, and it's ready to go in the plane. I hope you found this video entertaining, and perhaps you learned something to help on your project. Help me by hitting the subscribe button. There's lots of videos in the pipeline, and you won't want to miss them.